Hi, I'm Dwayne Williams from Amphenol Canada Corp. Today we're talking about industrial Ethernet and some of the capabilities and applications we use them into. First, I'd like to, talk about what kind of started all these development in the factory and process automation for industrial Ethernet. We see several trends related to this increase in demand, and with the work of quality and lead time and cost reductions of products, we kind of see these as a driving force for automation and real-time process control. The industrial Ethernet of Things is a natural extension of IoT, enabling factory automation equipment and systems that interact with each other. And the communication between these devices are becoming more complex, where we see all these independent subsystems and networks developed, and the increase in data volume that requires these faster rates between devices and control systems. And I think the growth of number of devices requiring more connections and the shrinking equipment with different port densities that must be increased with compact interconnects. This is what's needed, and some of these more harsher environments in the factory sector, a lot of moving machinery and environmental factors like temperature and humidity. These rugged interconnects are needed to function reliably in such environments. And the rapid growth in the number of sensors and devices that are powering these devices, this is where we see industrial Ethernet taking off and really being needed to apply to these factors. And there are a lot of existing manufacturing plants that will need to adopt all these new systems into their existing ones. And so it's essential that the equipment protocols talk to the old heritage equipment. So there are several types of factors driving this industrial revolution. So the development in, let's jump to my next slide here. So the Ethernet of Things operating in different speeds being used for all different Ethernet compatible with each other. So Ethernet is being used across a wide spectrum of industries, and it's rapidly being adopted protocol of choice in the industrial automation sector. So obviously, Ethernet was invented way back in the 80s with different performance ratings that are standard to 10 megabit, and now it's been really grown to the 10 GE up to like 100. The evolution really is faster speed unfolding now. So the industrial automation, building automation, which once operated at a lower spectrum up to 10G, the Ethernet adoption in this market was relatively slow. So mainly because the automation process equipment themselves weren't that particularly demanding. However, with Industry 4.0, it's changing this, and the rapid widespread adoption of industrial Ethernet standards is enabling this development, a whole new class of smart devices and equipment systems. And the development of the manufacturing technology has taken place for centuries with rapid expansion in the last few hundred years through advancements in machines, materials, and power following computers and the internet. This has enabled greater degrees of automated manufacturing and the standards we see today. And the explosion in manufacturing technology has really created this huge differential industry for connection interfaces, including power connectors and cables to multi-contact. One connector type that has been relatively widespread adopted is the RJ45, right? Which has really taken on many different applications, including industrial equipment. And although the RJ45 has been pushed to the extent of its performance capabilities to support all these connections, they present some limitations, including their physical size, form factor, and mechanical attributes, such as their single port plastic plug latches. So we have reached a point where RJ45 connector can no longer do the job for all of these next gen applications. So new solutions are needed. So it's helpful to understand how data communication within a manufacturing interconnect system is used and why it's evolved. A typical automated factory facility today uses numerous functional layers from enterprise level to the top where business is planning, logistics, and all other administrative functions take place down the factory floor, like individual component level, sensors, actuators, motors, and other devices that do their work. In between these layers are increasing levels of devices, control systems, and process controls. And in a typical organization, Ethernet is already well established as a protocol of all these levels. However, as we get down into the process control devices, these sensors and levels, there are some distinct communication systems that have evolved, including various field bus protocols that don't necessarily talk to each other. So while equipment on one level function using one protocol, they are typically locked out of communication to the next layer above or below. Without going through a protocol conversion process using these devices, they're called gateways. So this results in additional equipment costs, which can slow down data communication and speed. So that's why we see industrial Ethernet as one control and one communication to kind of bridge that cost savings and give it that communication to all these levels. And the protocol conversion that I spoke about, and the additional cost that you could save, and really the speed and latency and limited scalability. So with the transition to full Ethernet connected factories, the limitations of these models are removed because there's a single network and a single protocol and common interfaces. These are some of the key advantages. So there's no protocol conversion required between these layers, eliminating the need for expensive gateway equipments and reducing overall cost. This also reduces data lag associated with conversion processes, enabling real-time data process, expanding the scalability of plant and allowing devices to be added as needed. Every connected device is addressed using Ethernet protocol, enabling communication from all levels. And another advantage is that factories can develop a digital twin or a fully simulated process that mirrors an actual process and uses data collected in real time to analyze and compare actual performance against design processes. In addition to providing a capability designed to simulate this process and the implementation, the actual process can be monitored, adjusted, and match the simulation, as well as the simulation to accommodate a real-world equipment performance. And once it's fine-tuned, the digital twin can be used both as to diagnose and predict issues, which minimize downtime and optimize the process flow, which is very key for factories today. And of course, reduce costs for maintenance and downtime, and keeping that scalability functioning and real-time data. And the key between all these factors is communication, one equipment, and just a seamless process which could monitor and diagnose issues that may arise. So to summarize, the hierarchical automation model uses an independent communication system at different levels, while the Ethernet model creates a single network in which all devices have an IP address with all the enhanced functional that enables it to perform at a really optimal level. To bring back to an internet perspective and how it fits into industrial Ethernet model, I'd like to talk about some of the newest interfaces that have been developed for these applications. As I mentioned, RJ45 has been adapted very successfully in the industrial space. They're firmly entrenched and will continue to be so for many years. However, their limitation and growing needs for reduced space, increased levels of performance, there are new interfaces addressing these limitations and offering significant advantages. The IX Industrial and Single Pair Ethernet, also known as SPE, standards were developed with industrial Ethernet connectivity as their primary design criteria. So these products are taking their place in the new Ethernet-based manufacturing model. While a large variety of existing industrial interconnects will continue to be used to some extent, the new data-driven industrial Ethernet automation model will benefit from the use of IX Industrial and SPE, also known as Single Pair Ethernet. These two interfaces offer a number of key features and advantages. Their smaller form factor, rugged design, data performance, and signal integrity capabilities, support for powering devices over a data line, and key factors like being standards-based and availability in IP20 and IP6X sealed configurations makes them ideal for industrial applications. They have 4 times better performance than RJ45 connector in maiden retention and is much easier to terminate. So size does play a very important role in industrial applications. When compared to the size of an RJ45 connector, it's easy to see the size advantage, both of IX and SPE. The SPE and IX is about 75% smaller than a typical RJ45 in total space, volume, footprint, which enables higher port density. The IP20 IX Industrial can be placed on a 10mm pitch, which is half of what can be done on an RJ45, meaning you can double the number of ports in a typical multi-port application, such as the Ethernet switch. And from a cabling perspective, single-pair Ethernet enables only two contacts for single-pair or two-wire cable, whereas IX is designed to accommodate four pairs of wire for high-bandwidth Ethernet. And due to SPE only using two wires, the cable is smaller, lighter, more flexible, and costs less, so it's easier and less expensive to run more cables to as many devices. IX Industrial supports 4-pair or 8-wire Ethernet, enabling greater bandwidth. And the IX connector have 10 contacts, so there are additional 2 wires for power or other types of signals that may be required. From a signal integrity point of view, it's critical in industrial designs. This essentially means maintaining accuracy and the transmitted information that is received at the other end. It is critical in any high-speed data network to ensure it operates smoothly. Both SPE and IX exceed defined signal integrity performance standards for insertion loss and return loss. SPE provides Cat5 or 1 gigabit performance up to 40 meters, and 10 base T or 10 megabit performance up to 1 kilometer, while IX provides Cat6A 10 gigabit performance up to 100 meters. This makes IX perfect for high bandwidth, high data communication between levels of the manufacturing structure, while SPE is optimized to provide necessary bandwidth and performance for individual devices such as sensors over long distances to support real-time error-free performance in the network. Both SPE and IX provide power over individual devices, which eliminate the need for additional external power delivery and could save cost in reducing the amount of connectors needed for a network. For SPE, it is referred to as Power over Data Link, or PODL, also termed as POODLE, and the IEEE standards 802.3CG specifies the delivery of 50 watt of power over cable lengths of 150 meters in length and 1.2 watt of power up to 1 kilometer. POODLE, or PODL, is its own designation and specifically tailored to single-pair Ethernet. IX Industrial is governed by the highest level of standards. IEEE 802.3BT, or PoE++, would specify 100 watt of power using all 4 pairs over 40 meter of cable. However, both IX and SPE have current ratings allowing them to exceed maximum specified levels, meaning they are capable of even higher levels of power handling beyond the current standards. The standardized mechanical interfaces and performance specs provided plug-and-play capability, simplifying the servicing and addition of new devices in the network. Both SPE and IX Industrial are governed by established standards, which are IEC standards. Amphenol products are fully interchangeable and can mate and function with products from other authorized manufacturers, meeting the same standards. Amphenol is a member of the Industrial Partner Network, which is governed by single-pair Ethernet. And IEC 63171-6 is the international standard that governs SPE that specifies a two-way or four-way data over power shielded connector, including both free and fixed types, for data transmission rates of up to 600 megahertz. And IX Industrial connectors conform to IEC 61076-3-124 and offer Cat6A 10 megabit performance for up to 10 gig of Ethernet communication, compatible with 100 base T or 1000 base T, and 10 gigabit protocols. This ensures security of supply, multiple sourcing, and reliable performance, in contrast to some of other interfaces that are not as rigorously controlled or may not be standard interfaces. So these are well-established standards that follow a specific guideline, and these are the advantages of being one common interface. Well, so to provide optimal performance in an electrical noisy environment, like a manufacturing plant, it is critical to make sure that shielded and the sensitivity data lines are properly radiated from the electromagnetics. Both SPE and IX connectors feature fully 360-degree shielded designs, providing a completely protected connection through the mated interface. And to contact a design of the IX and its low normal force, it supports a high mating cycle for a very durable long life interface, up to 5,000 mating cycles. This feature ensures superior AMI control, which is so critical in uninterrupted, reliable performance. Both SPE and IX feature IP20 fingerproof designs, meaning they are recessed inside the connector so they cannot be touched in the unmated condition, protecting both person handling the connector as well as the connector itself. The IP20 version is suitable for many applications on the shop floor, as well as in protected environments, but for situations requiring a greater degree of protection from dust or fluid incursion, we do have IP6X and IP67 versions also available. And reliability is very critical in these industrial applications. One extremely important feature of these industrial interfaces is the connector latching mechanism. Reliable latching is critical to ensure connectors stay properly mated and avoid disrupting the signal, and it is also important that latching features are rugged enough to withstand potential damage or breakage. Standard RJ45 plug has a simple molded plastic latch, which is known to be weak and easily broken, making it unsuitable for applications which could be mechanical rough handling. In contrast, both SPE and IX industrial plugs feature metal latching mechanisms, and IX provide a 2-point latch rated at 80 Newton minimum on latching force, ensuring reliable performance in critical applications. Because you will certainly need different lengths of cabling for different applications, it's important to customize cables. The field where installing equipment and length requirements can vary, so having field installable plugs is very valuable. Both SPE and IX plug kits are available with integrated IDC installation and displaced contacts, which allow a cut wire to be terminated to the contact without stripping it. Connectors are designed to make it easy to trim to locate the wires properly for IDC connection. With a special tool available to simply terminating all the wires at once for the IX plug. Both IX and SPE also featured integrated cable strain relief mechanism to make sure the terminations are protected from undue cable stresses. Amphenol also provides a variety of standard cable lengths, assembling and can be customized to meet specific applications of the customer. Cables can be provided with the same connector at each end in an adapter style, and for instance, a hybrid cable, which we've seen a lot of customers purchasing, IX to RJ45, which can facilitate integrating IX equipment into the legacy systems that RJ might be being used today. The cables can also be provided in a pigtail configuration with a connector at one end and an undetermined other end, ready for user to terminate themselves as needed. And another important feature of the IX Industrial is the keyed housing to ensure correct mating to various applications. Currently available with an A key or a B key, a C key is also being developed. While the application of the A key and B key and C key are suggested for IEC standards for different purposes, in fact, the connectors are identical from a performance standpoint, so the keying can be used for the full Cat6a 10 gigabit applications. IP20 versions provide finger protection for safety reasons, which is perfect for controlled environments. But industrial environments can also be full of dust and particle contamination, as well as fluids, which can be a cause for concern. Both IX and SPE are readily available in IP6X configuration for applications where protection against dust or particulate contamination are required, as well as water incursion during submersion or spray. The IX IP67 connectors feature a rectangular format with a push-pull latching plug housing, which seals and locks the maiden bulkhead, just like the image you can see there in the top left. The equipment itself utilizes a standard IP20 PCB mount receptacle. Field terminable plugs are available, as well as pre-made cable assemblies, just like the IP20 versions. The SPE IP6X interface uses a circular form factor in the same size as an M12 connector, with a push-pull coupling ring to ensure a positive latching mating receptacle, which are panel mounted. A sealing is accomplished using internal O-rings. The SPE IP67 cables are also available in multiple configurations. Most Ethernet connections require magnetics at a receptacle to provide the correct communication to the PHY chip. These magnetics components include transformers and chokes providing galvanic isolation and DC biasing, as well as common cable noise injection, which are typically mounted on the PCB. Like the RJ mag connectors, which are RJ45 with integrated magnetics, the IX industrial receptacle now also provides this option in our newly released product. This offers a huge advantage with regard to preserving board space and other important electronics, as well as providing optimized performance by eliminating the PCB traces between the connector and the magnetic component. Amphenol provides one of the only IX mag on the market today, with the benefit of maintaining a 10mm center to center pitch between connectors, allowing for high port density as a standard version. It also supports PoE++ performance for 100 watt of power and higher to sensors and to actuators. This product is already launched and fully available in distribution. Another new product is our industrial RJ plug, which features multiple cable exits, flexibility for enhanced cable management in different applications. It also supports gigabit Ethernet protocols and 10 gig links in applications up to 100 meters. Field terminable IDC plugs with solder options, ease of custom cabling or repair in the field with IDC contacts. Cast metal body and stainless steel latches, rugged construction and latching resists damage and ensures reliable latching, plus full shielding. Now looking at new products, launches, and future developments. Top left is a SPE splitter using the IEC 63171-6 interface. The split offers individual data drops, and the design is complete with initial engineering samples available. With such target applications as factory automation, with less cabling as one of the key benefits, to multiple devices that are connected without the need of additional switches. And at the bottom is a SPE with magnetics, which offers a 10 base T1L with longer distances. And the design is complete with engineering samples also available with 10 megabit prototypes. Applications that we target is automation and robotics. We believe customers would see this as a unique and differentiated technology, and Amphenol was one of the first to market with the SPE magnetics. Also on offer in development is a plug connector and cable carrying extra power with 2 pairs of pins over the SPE pair. Also targeting motors, sensors, and application robotics where additional power is needed. The single pair partner network is jointly driving the interface for M12 hybrid single pair Ethernet and power interfaces. And there's a new standard which is called IEC 63171-7, initiated by the network's founding member, TE Connectivity in 2021, and the logical development is an M8 hybrid, different form factor, and the SPE power interfaces, which is already published by the leading members of the network. Some highlights so far are different codings to distinguish different voltages. And it also has the robustness of the previous connector, but in this case, it also has IP67 rating in also the M12 form factor in the mated position. And new to Amphenol, this last Q4 2024, the new product that we launched was the low smoke zero halogen IX cables, also known as LS/LH cables. Some of the key features and benefits are low smoke zero halogen cables are designed with special insulation and sheathing that minimize smoke emission and eliminate halogen-based toxins when exposed to fire. The illustration to the right, where you can see clearly the PVC emits smoke, whereas the low smoke zero halogen does not. Other advantages are why customers are moving to these types of cables. The low smoke zero halogen jackets have a lower coefficient of friction than some of the non-low smoke zero halogen jackets, which can make installation much easier. There's also cost efficiency. Our durable design leads to fewer replacements and repairs over time, saving you money and minimizing downtime in your network. And they also meet compliance, regulatory compliance that are stringent safety regulations and standards that easily conform to low smoke zero halogen cables, providing peace of mind for compliance and environmental responsibility. And also still with a robust design, which are constructed to withstand extreme conditions These cables are resistant to abrasion, chemicals, and extreme temperatures, ensuring long-lasting, reliable, integrated low smoke zero halogen cables into your products. You invest in safety and sustainability and reliability, which are key factors in modern infrastructure. Also a new launch, which is just in Q2 of 2025, is a new IX product that has been successfully adopted by other customers, the IX right angle cables and connectors. In applications where cable management and organization are critical for efficiency, safety, and reliability, the right angle or 90-degree upward and downward cabling solutions offer several key factors and benefits. Cost efficiency in the beginning, although it might be a little bit higher at first, the increased durability and reduced maintenance requirements can lead to lower overall replacement costs in the long run. With reduced cable stress, by routing the cables at a 90-degree angle, the stress of the cable is reduced, minimizing wear and tear and prolonging the cable life. Other benefits include safety by preventing cables from being tripping hazard. A right angle cabling contributes to a safer work environment. And the compatibility of the right angle connectors can be compatible with various types of cables, example Ethernet, power, fiber optic, allowing for versatile applications. These versatile routing options are designed to allow for flexible routing, accommodating different installation scenarios, whether the cable in trays or racks or in mounted setups. And the improved accessibility of the right angle cables can enhance accessibility in tight spaces, making it easier to connect and disconnect cables without the need for extra clearance. In summary, utilizing the right angle 90-degree cables and upward or downward cabling in industrial applications, these enhance and improve the safety, increasing efficiency, and contributes to the longevity of the cable infrastructure. Also on the product roadmap, we do have functional and developed field installable SPE with a more rugged, robust housing, using the same interface as the IP20 version. This is ready to launch soon as we have more developments and customer interest. Other products in development like SPE with PCB plug and SPE rectangular IP67 shown to the right, we are always one step ahead with innovation and being the first to market with new designs. Looking at applications for these connectors. Inside a typical industrial cabinet on the factory floor, we find devices such as programmable logic controllers, port switches, central controllers, power supplies, relays, vision systems, and other types of equipment depending on the application. Our solutions offer simplified cabling, less installation space, and savings in weight, especially for gigabit Ethernet. And these are ideal for applications where highly flexible, lightweight cables are needed. Single-pair Ethernet, or SPE, and IX industrial connectors and cables ensure seamless data exchange between machinery, sensors, and controllers. This is especially important in complex manufacturing process where reliable, high-speed communication is critical in industrial environments, which allows for real-time feedback for vision systems, force sensors, and actuators. These products enhance scalability for future expansion and Industry 4.0 readiness. Importantly, reducing downtime with predictive maintenance and diagnostics through continuous data flow. In an Ethernet-based automated control system, these devices communicate with each other with a variety of actuators which provide physical and motion control, all types of sensors, control devices, pumps, and more, HMI or human machine interface, such as display panels, cameras and vision systems for security, data loggers, which provide measurements for various parameters, and robotics, which can take many forms, from simple to very sophisticated. Many of these devices are self-powered, no external power source, so they rely on the power being delivered through the SPE and the IX data connections, using power over data link or PoE. Now looking at real-world applications and success stories where industrial Ethernet products are really making a difference. First, in aviation, there's in-flight entertainment system with 4K monitors, utilizing IX Industrial. This is the next generation where a very thin and lightweight interface requiring very low profile connectors can achieve 10 gigabit and are vibration resistant. IX Industrial met these specifications and are the winning solution. To the bottom left, teaching pendant for robotic arm connected to human machine interface, or HMI, and a programmable logic controlled PLC controlled robot. This device can program the industrial robots remotely or manually. IX was an ideal fit due to space constraints and needing high performance in this application. These industrial robots are designed and programmed to optimize automation, ensure consistent quality, and to reduce overall cost of an operation. And to the top right, SBE integrated communication controller with a 5-chip from different manufacturers are connected to this interface. One-stop shop with many other connectors. To the top, you can see the SBE in a vehicle switch. This is for a vision camera system or a backup camera. This was very good application, and the winning reason was it's very lightweight with a single pair Ethernet cabling, and over a long distance and a low profile of the connector, it was ideal for this application. SBE provides a simplified approach compared to the traditional multi-pair Ethernet. By requiring a single pair of wires over the communication, this reduces the weight and space requirements. And lastly, at the bottom right, a power distribution unit incorporating a hybrid RJ and IX interface. IX was chosen due to needing to secure latch in an environment where on-mating could interrupt critical data collection. IX industrial connectors are being favored for their durable resistance to environmental factors, making them suitable for harsh environments and these conditions we see today. There's a growing trend towards miniaturization and connectors in industrial environments, which allows for more efficient use of space devices and machinery. This momentum is being realized due to the ability to offer reliable connectivity in compact design. And in addition to penetrating these traditional market space for data telecommunication, IX and SBE are taking root in new designs such as EV charging, robotic arm applications, where flexibility and high performance is paramount. Manufacturers are launching new products and solutions that leverage SBE and IX industrial technology to enhance industrial automation and connectivity. And looking at one of our newer products utilizing a hybrid power supply, this multi-drop SBE can be used inside a switch cabinet or field cabling, with the main benefit of a significant weight savings to reduce the cost and complexity of connecting devices and enabling advantages of the Ethernet connectivity to edge sensors and actuators, or can just be used to connect different devices using Ethernet protocol without the use of a switch. Single-player multi-drop is pushing further to double the distance. Shown on the screen is 25 meters, but in the future, we're looking at 50 meters and 16 nodes, which is expected to launch next year. Transmission lengths and data rate are also important issues to take into consideration. Ethernet protocol is well suited to different types of devices and equipment being used at various transmission distances, connected to new technology like IX Industrial and SBE. Sensors and actuators used in factory and process automation environments, as well as vehicular networks like trains and trams, running at longer transmission distances up to 1 kilometer, typically use less power and have dedicated functions designed to work well with lower data rates like 10 or 100 megabits. SBE, with its power over data link or POODLE capability, is an ideal connection interface for these applications. As data requirements increase and link lengths get shorter, SBE functioning up to 1 gigabit can deliver even more power for devices like industrial PCs or displays, and also motor drive controllers. Then, as data rates increase even further to 10 gigabits for more complex and higher powered devices such as vision equipment and medical technology, IX Industrial provides the Cat6a performance needed at power levels up to 100 watts. The path to even higher data rates up to 100 gigabit will be enabled by the future generation of these interconnects. And to close in summary, to recap, Amphenol is always at the cutting edge of new technology. We're always bringing out new products and one step ahead of the trends that we're committed to offering for the next generation of industrial Ethernet connectors. Amphenol has a strong product offering that is expanding and keeping up with the rapidly growing industrial Ethernet market. You will see more new products coming this way in the near future. Amphenol has a proven track record of being first to market with products and evolving industrial standards and technologies, and is anticipating the future needs for more generations of products. Amphenol also provides very competitive pricing, shorter lead times, and lower MFUs than some of our larger competitors. Our goal is simple: to be easy to work with, provide competitive pricing, and to win business and keeping these solutions and service to our customers at a top level and help drive their success. Thank you. That's the end of my presentation.